The avian respiratory system exchanges oxygen and carbon dioxide between the gas and the blood utilizing a relatively small, rigid, flow-through lung, and a system of air sacs that act as bellows to move the gas through the lung. Gas movement through the paleopulmonic parabronchi, the main gas-exchanging bronchi, in the lung is in the same direction during both inspiration and expiration, i.e., from the mediodorsal secondary bronchi to the medioventral secondary bronchi. During inspiration, acceleration of the gas at the segmentum accelerans of the primary bronchus increases gas velocity so it does not enter the medioventral secondary bronchi. During expiration, airway resistance is increased in the intrapulmonary primary bronchus because of dynamic compression causing gas to enter the mediodorsal secondary bronchi. Reduction in airflow velocity may decrease the efficiency of this aerodynamic valving and thereby decrease the efficiency of gas exchange. The convective gas flow in the avian parabronchus is orientated at a 90-degree angle with respect to the parabronchial blood flow, hence, the cross-current designation of this gas exchanger. With this design, the partial pressure of oxygen in the blood leaving the parabronchus can be higher than that in the gas exiting this structure, giving the avian lung a high gas exchange efficacy. The relationship of the partial pressure of oxygen in the moist-inspired gas to that in the blood leaving the lung is dependent on the rate of ventilation. A low ventilation rate may produce low oxygen partial pressure in part of the parabronchus, thereby inducing hypoxic vasoconstriction in the pulmonary arterioles supplying this region. Inhaled foreign particles are removed by nasal mucociliary action, by escalator in the trachea, primary bronchi, and secondary bronchi. Small particles that enter parabronchi appear to be phagocytized by the epithelial cells in atria and infundibulum. These particles can be transported to interstitial macrophages, but the disposition of the particles from this site is unknown. The predominant site of respiratory infections in the caudal air sacs, compared to other parts of the respiratory system, can be explained by the gas flow pathway and the mechanisms present in the parabronchi for particle removal.